In the video I shared, you can see my project demonstrating a simple yet functional circuit designed to control a DC motor using an on-off button. The goal of this project is to showcase how a digital input like a push button can be used to control the operation of a motor. When the button is pressed, the motor starts spinning. To make the motor's motion clearly visible, I attached a small piece of duct tape to its shaft, which serves as a visual indicator of the motor's rotation. Pressing the button again stops the motor completely. This project demonstrates the basics of a motor control, showing how a digital signal can translate into mechanical motion. Let's go over the code that powers this circuit. The program is written for an Arduino Mega 2560 and is simple but effective in controlling the motor based on the button state. At the start of the code, I defined two constants, one for the button pin and another for the motor pin. For instance, the button might be connected to 3, but the motor to pin 9. These constants make the code easy to read and modify later. In the setup function, I specified the button pin as an input and the motor pin as an output using the pin mode function. This ensures that the Arduino can correctly read the state of the button and control the motor accordingly. The main logic of the program is the loop function. Here, I use the digital read function to check the state of the button. If the button is pressed, the pin reads high. The motor pin is set to high using digital write, which turns the motor on. If the button is not pressed, the pin reads low. The motor pin is set to low, turning the motor off. This simple logic ensures that the motor only runs when the button is pressed, providing a straightforward on-off control mechanism. The control is clean, efficient, and it perfectly complements the physical design of the circuit. Now let's look at the schematic and explain the role of each component. The Arduino Mega 2560 is the core of this project. It processes a signal from the button and controls the motor accordingly. It supplies the necessary logic for an on-off functionality and powers the motor through the motor control circuit. The DC motor is the main output device of the circuit. It spins when the motor pin is set to high, and it stops when the pin is set to low. The attached duct tape makes its motion easier to see, especially during testing. On-off button. The button is a digital input device. When pressed, it sends a high signal to the Arduino, which turns the motor on. When released, it sends a low signal, turning the motor off. This simple input mechanism allows for manual control of the motor. The transistor. The motor is powered indirectly through a transistor, which acts as a switch. Since the Arduino cannot supply enough current to power the motor directly, the transistor amplifies the signal from the Arduino, allowing the motor to run safely and efficiently. A diode is connected across the motor terminals to protect the circuit from voltage spikes caused by the motor's indirect load. When the motor is turned off, it can generate a sudden reverse voltage that could damage other components. The diode acts as a safety feature to ensure the longevity and safety of the circuit. Overall, this product showcases how simple components like a button with a transistor combined with the Arduino can effectively control a motor, demonstrating the basics of digital input and motor operation.